I have in front of me 5 random packages, therefore it must be time for another mailbag. Let's get things started with this relatively big and relatively heavy one. It says digital voltmeter module, and that one piece of that, and 1x expansion board module. So who knows what it really is. Okay, a few things here. Let's take a closer look. First thing, you certainly should know what this is. These are 5 breadboards. These are the 830 type points. And there's nothing too special to say about these. The standard with the square holes, not the round ones. Let's see what the insertion force is like. Yeah, it's just about average. It's a little tight. It's not exactly super high quality, but it'll work just fine. The reason I got these is because I was actually starting to run out. I have a lot of projects sort of on the go which are populated on some boards, so I needed some extra boards to have aside so I can do separate things, more separate things. I think these cost me about $1.50 each, or maybe about $2 each Canadian, but that's because our currency is not very good. It's got the sticky back, the back side here, which I never peel, I always leave it on. And yeah, these are the bigger ones, you know. There's some smaller ones. There's some bigger than these still, but yeah. This one though, this other item in the same bag is quite interesting. This is an LED matrix. If you can see, this 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8, so 64 LED matrix. But what's so special about this is actually a set of NeoPixels. So this one was kind of expensive. It was probably like $5-6, something like that. I say expensive. It's not really expensive, but it's just expensive by China standards. I got this so I can have a look and see if I can control more NeoPixels and have more interesting patterns come out of it. So I'm actually really excited to see how this module is going to work. So nothing much to say now. We have to actually hook this up to an Arduino and power it up before anything is said about it. I think actually the corners, I think this panel is routed. Yes, it is. So you can break off the edges here, which I'll probably end up doing just in a safer manner. But until then, let's go on to the next one. Next one up is this one, which is cable wire connector. Hopefully that's accurate as to what's inside. It is actually. Let's take a close look at what these are. So what these are Wago style connectors with these little lever locks. So basically how it works is you open this lever. I don't know if you can see on the inside there. So you open this lever, you see that metal blade just moved out? See there's metal blades in these 2 holes but not in that last one. You shove a wire down there and you shut it, and you're supposed to be able to connect all 3 of these together, right? These 3 would be connected together. So if you get a 2 conductor wire, you'd have to use 2 of these. And then, yeah, it's supposed to do a secure connection. Wago, the brand name Wago, is supposed to be able to go into walls. It's supposed to be legal to use up to electrical code. But I just want these to do low voltage DC stuff, and which is why I'm not too concerned if these are not legit Wago. They're Chinese clones, to say the least. So let me give it a shot here. I'll open up all 3 of these, and I've got some different wires to try. So this one here, I believe it's 18 gauge and it's stranded. So I'm gonna shove that in, give it a good twist, shove that in there, and it should close. So that's closed. I'm gonna give that a tug. It's quite strong. It moved a little, but this is actually really impressive, the hold. Now I've got this 24 gauge solid core wire. This should actually be a little bit more challenging for this nut. Actually, that is quite solid. That's really good. And then I have this ultra tiny, this is a 30 gauge stranded. That pretty much runs the gamut of the stuff I use around here. Throw this 30 gauge in. Well, I broke the wire and not the connection, so that's a good sign, right? If your wire breaks before your connecting method does, that's pretty much the goal. So let me strip back some more of this. So basically it does lock on to all three of these, and then you even have a little test point here where you can shove a probe down to have a test, which is really good design. I like this. I don't know if I'd be able to use this on 110 volt AC. I don't think I'd have too many qualms about it if it was just here on the workbench, but I don't think I'd want to use this in the wall, right? I can't really verify the integrity of the connection when it's stuck inside the wall. If it's outside, I can feel it. If it's hot, you can smell it. You never really have your stuff on your workbench going while you're not there. But in the wall, I think I'd be a bit more scared. I'm going to try these DuPont headers now, see if you can connect using those. Yeah, certainly is working. So I think this is a good solution for doing temporary hookups of things. Ouch! Careful, that's a heavy spring. I just pinched my finger. So yeah, these things look pretty good. I got 10 of them here, I believe. 2, 4, 6, 8, 10. Yep. And I think they were just about $2 for all 10. So that's actually a fairly good deal. And I do like them, so I may order some more. I'm not quite sure where I'm going to use them, but I do have upcoming projects that should make good use of them. So yeah, let's go on to the next one. Next one is this package, and it says T10 Carbulbs LED Aero. I think I managed to cut right into the one bulb there. Oh, that's actually cooler than I thought. So let's have a look at this thing. So pretty much immediately I was thinking that it's one of those bulbs that I purchased late nights on auctions on eBay. And it is that, but it's actually bigger than the gauge cluster bulbs that I looked at before. This one actually seems fairly bright. If you look, there's a lot of chips on the surface here. A whole bunch of them. The polarity is written down, so the positive's on this side. So, I mean, we need to power this up. And I think this is one of those, where they said error, it meant error-free, like the CAN bus ones, the ones that detect faults. I think it's not going to give you a code if you put these in instead of the filament bulb. That remains to be seen, but we shall see. There's only one way to find out, huh? It's to test it. Crock lead here is quite slippery, the silicone covering. Alright, so let's give this a shot. I'm going to try to set this to 12 volts. Actually, you know what, let's just go straight to the worst case scenario. We'll go like 14 volts. And see how much current this thing draws. 13 and 14 volts. Give her. Ooh, that's like blue. It's pretty much entirely blue. Maybe it's like super white, but I'm pretty sure it's blue. It's blindingly bright, and it's pulling about 200 milliamps. It's going up and down. That's odd. It's not pulse width modulating itself. Huh. That's quite interesting. So it's not even warm. You know what? It can't be white. It has to be a bluish because there's no phosphor on the top coating here. There might be a tiny bit, but not very much. So let's see what happens if we cut this heat shrink off. Don't think I'll be using a blue bulb in my car anytime soon. Oh, come on. Don't make me slip and hurt myself. Okay, so wow, that is special. So they have those two cobs here that we could probably salvage. And then they have a resistor, surface mount resistor, soldered between the positive pad and the leg. And that is a 39R2, so 39.2 ohms, and the other one's flipped upside down. Fantastic. That's actually interesting. There's a little piece of leg of LED sticking up there. That is astonishingly cheaply made. That's crazy. Is this mounted solidly, the LED chip? I think so. It's probably epoxied on there, on this little PCB. Wow. That's actually impressive and disappointing all at the same time. The level of cheapness that they managed to get this, but then somebody hand soldered friggin' tiny little resistors on there. I guess that's what I get for paying a cent or so. I don't know if this was a 1 penny win or under 20 cents or something, but yeah, cheap as chips. So let's move on to the next one. Next up is this one. All it says on this guy, it's pretty small, is ELEC, $1.39 value. Alright, let's have a closer look at what this is. So what this is are 0805 100 nanofarad, 0805 size I should say, 100 nanofarad ceramic capacitors, surface mount, tiny little guys. And there's not much to show except that I got 100 of these and they were about $1.50 or so. I want to see if I can test one though. Not sure if I'll be able to. If you remember back to my transistor testing horror show. But I think I have a plan this time. So can you even see that speck of grain of rice there? Tiny little thing. Tiny, right? So I do have these pliers here, these tweezers that connect to my multimeter. And my multimeter does have a capacitance tester, although I don't think it's that accurate. This is supposed to be 100 nano, so it should be, yeah, I'm not sure about the range. It says 0. nanofarads, so it should be 100 times this, but let's see what happens if I give this a squeeze. Ooh, look at that. 150 nanofarads. Wow, that's high. I'm going to flip it around and see if it makes any difference. Wow, look at that, 150 nanofarads. So I'm not sure how accurate this is. I'm pretty sure it's not particularly accurate, but that's pretty impressive. Let's see, I do have a ceramic cap, a more traditional one here, 104. I believe that's 100 nano as well. I'm not sure if it's 100 or 10. I'm not particularly good at the very small numbers. I think it's supposed to be 100 nano, but it's giving me like 80 maybe. I put more tension on it. That's interesting that this little multi-layer ceramic is giving me way more, like 150 nano. That's a lot. But anyways, I just got these to make decoupling, to use them as decoupling caps. And I figured I am going to start making SMD projects shortly, and I would like to have some on hand, some of these capacitors. So if I do decide to make boards at home, I'll have some basic components ready to go. Plus these things were extremely cheap. I mean, $1.50 for 100 of them, so 1.5 cents a piece. That's not bad. Oh, actually, they actually wrote it down, 100 nanofarad. All right, that's pretty cool. Got this tested. Let's go on to the next one. I feel like it's going so quickly today, but anyways, this is package number 5. So let's try not to cut into it, and it says digital or digitali voltmetro, something like that. Digital voltmeter, I think they were trying to say. Did order some, so it would make sense. Yeah, voltmeter indeed. Let's have a closer look. So what these are, they should be panel mount little voltmeters. These only cost me about $1 and some, maybe $1.30 each. Not very expensive, but they would be handy to just quickly have an idea of the voltage of certain things. So how am I going to test these now? Well, actually I have an idea. I'm not sure what the maximum voltage these guys could read, but I do know a way we can test them. So we just got these blocks. So what we can do is we can combine all of the leads together and then tie them all up to the same source and see what we get. So let's give that a shot. Now this is the type with 2 wires. There are some with 3 wires. The only difference really is that the 2 wire senses the voltage on the same wire that it gets powered from. Alright, going to try to shut this without pinching myself this time. That's one. So this one's just easier to connect, but I believe it has a lower sense voltage because there's no way to protect the insides from the higher voltage since it needs to power the little micro on board. Hopefully I'm doing this relatively in shot. Man, these things have the cheapest wires. You can actually desolder them. See right there. And resolder better, thicker wires. Hopefully that's in. I hope I'm not grabbing the insulation. It's hard to see inside of the connector to see if the insulation is caught or not. 1 and 2. This has horrible PVC jacketed wires. I do have small silicone wire I can use though, so it's not that big of a deal. Alright, that's one. Open up another one. Wow, the spring is incredibly stiff on these. That's amazing. I'm liking it already. Alright, so that's one. That is 2. And that is 3. Whoop. That is 3. There we go. Alright, now, how am I going to power this, you say? I will use the test port right down there to see if I can get this to work. Should probably use some sticky tack here. So I'm going to try to put it kind of at the bottom of the frame here so you can see all 3 of them. That's 1. That's 2. And that's 3. I guess if this was a 4-way clip, it'd go a lot better than these 3 ways, but you know, we do what we can. Alright, well, I've got some wire. Same deal, but just these wires are more pokey, so I'm able to make them stay inside of these blocks. So 1 and 2. Okay, now I shouldn't have to worry too much about the voltage drop through these wires since the voltages should be negligible, or the current, I'm sorry, should be negligible, and therefore whatever resistance is in the wire will also be negligible. I'm having issues with my clamps here. They're not, they're so slippery on the silicone. They're not letting me get a good handle on it. Oops, and I put that on the wrong one. I should use different colors, but you know, production budget and such. 1 and 2. Okay, so I'm going to power these. Let's start low. I'm not sure what the max voltage is, but I'm guessing it's fairly low, so I'll start at 5. I need this to go up to at least, ideally 24 volts, but more realistically probably 12 volts. So there we go. Now we're feeding in. Let me just check here. Okay. Okay, so my power supply of unknown accuracy is saying 5 volts on the dot. So I'm going to pull these off. Maybe I won't pull the plastic, it's a little hard. But if you can see my meters here, so one says 4.66, the other one 4.66, the other one 4.65. I'm not sure what the actual voltage is. I could check that, however, with another inaccurate or accuracy unknown multimeter. So I'm going to hook this guy up, set it to DC volts. I'm going to go black to black, red to green. Oops, I have probably burnt my fuse. I was in current mode. Alright, so right now I'm reading 4.78, 4.76, 4.74, and my multimeter is reading 4.68. So these have dropped 6665. So actually I think that's fairly accurate. So my power supply is reading it at a totally different spot, so probably won't take my power supply into account too much. But if I can shove this up on top of the screen here, see there, 4.58, and these are all like 4.58, 4.59, 4.62. They're pretty close. I mean, they're good enough to give you an idea of what's going on. So I actually like this. That's really not bad. I think these would be just fine. And this lovely pile of stuff makes for today's mailbag. Thanks for watching.